For this problem, let's take a look at this cycloid defined by x is equal to 2t minus pi sine t and y is equal to 2 minus pi cosine t. This looks like kind of the Greek letter gamma, and it crosses itself twice at the point here, 0, 2. So this is the point 0, 2, 1, 2, 3, 4. The origin is here. And so it crosses here. So the problem is to find the equation of both tangent lines, the tangent line that comes this way and also the tangent line that comes this way at this point. All right, now to do this, we first have to solve for t. So find the values of t. To do this, we were going to use the second equation. Let's see where y, which is equal to 2 minus pi cosine t, where does that equal to? I need the y-coordinate of the curve to be equal to 2. Let's figure out where that happens. Okay, so that means that negative pi times cosine of t is equal to 0. So cosine of t is equal to 0. And the cosine function is equal to 0 when it is a half multiple of pi. So pi over 2, 3 pi over 2, 5 pi over 2, going the other direction, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. So there are an infinite numbers of values of t where the y-coordinate is equal to 2. And indeed, if you continue graphing this, it's going to go up and come down again if if I plotted this out further. Okay, now for only two of these values of t will the x-coordinate also be equal to 0. So let's see for which x-coordinates that happens. Well, as it turns out, if t is equal to pi over 2, okay, so let's take our first attempt, then x is going to be equal to 2 times t minus pi times the sine of t. So 2's cancel, I get pi. Sine of pi over 2 is 1, so I get pi times 1, and that's equal to 0. So the x-coordinate is 0, the y-coordinate is 2, and so that's one of the two places. The other place that this happens is going to be when t is equal to negative pi over 2. If x is equal to negative pi over 2, I get 2 times negative pi over 2 minus pi times the sine of negative pi over 2. So here I would get negative pi minus pi times negative 1. So negative pi plus pi cancels, and that is 0. And so these are the two values of t, the two times, so to speak, at which the function is going to be, or the parametric curve crosses through the point 0, 2. Okay, so that's the first part of the problem. The second part of the problem is now to find the tangent lines at this point. And so my equation for the tangent line is going to be dy dx is equal to dy dt over dx dt. Okay, dy dt, if I take the derivative of this, derivative of 2 is 0, negative pi is a constant, derivative of negative cosine is plus sine. So I would get that that the derivative of dy dt is going to be sine pi times the sine of t. Okay, the derivative of x with respect to t. So here I would have 2 minus the derivative of sine is cosine, so pi times the cosine of t. And now I need to plug in the two values here at that point. So first off, in the blue, dy dx when t is equal to pi over 2. So that's going to be equal to pi times the sine of pi over 2 over 2 minus pi times the cosine of pi over 2. All right, pi times 1 over 2 minus cosine of pi over 2 is 0. And so that works out to be pi over 2. And so the slope this direction works out to be pi over 2. For the other one in red, dy dx, evaluated at t is equal to negative pi over 2. That'll be equal to pi times the sine of negative pi over 2 all over 2 minus pi times the cosine of negative pi over 2. Okay, now the sine of negative pi over 2, that's equal to negative 1. 2 minus cosine of negative pi over 2, that's again 0. So the times pi doesn't change anything. And so this works out to be negative pi over 2. And so the slope in this direction works out to be negative pi over 2. So the equations of both tangent lines, we're going to have pi over 2 and negative pi over 2. So finally, the equations of the tangent lines. Okay, so the equation of tangent lines, I have the y-intercept is 2, and the slope is pi over 2 or negative pi over 2. So I've got everything I need. Y is equal to pi over 2 times x plus 2. That would be one in one equation. And the other one will be y is equal to negative pi over 2 times x plus 2. That would be the other line where the y-intercept is 2 and the slope is negative pi over 2. And so those are the equations of the two tangent lines to the curve as it passes through 0, 2.